Okay, in this podcast we're going to talk about the auto-ionization of water. We'll talk about KW, we'll talk about pH and POH, and how you go between them, and the hydrogen ion concentration and the hydroxide concentration. We can write an equation for the auto-ionization of water, where we take water and it dissociates into the hydronium ion and the hydroxide ion. We call this the auto-ionization of water, and at equilibrium, this lies very much to the left. As you know, water doesn't naturally dissociate into large quantities of acids and base, so the Kw is very small. We can write the shorthand for that, which is just that water becomes H plus and OH minus, although we know that H plus simply is our shorthand way of saying that we're forming the hydronium ion. So we're going to talk about Kw, which is the equilibrium constant for water. It is sometimes called the ion product constant for water, or the dissociation constant for water. But regardless, it's a K. It's an equilibrium concentration, which tells us the ratio of products over reactants at equilibrium. So it's Kw for water. Okay, so I can write the dissociation of water, which is this equation here. Water becomes H plus and OH minus. I can write my Kw for that, which is simply, as you know, these are both aqueous, so they're going to be in the numerator. It's going to be H plus times the concentration of OH minus. And because water is a liquid, it does not show up in the denominator. It's excluded. And I'm told that the dissociation constant, Kw, is 1 times 10 to the minus 14th, which is a tiny little number. Okay, but this is at 25 degrees C. And as you know, K changes with temperature, so this is just the value at 25. Alright, so if I write the equilibrium expression for the Kw, it's the concentration of H plus times the concentration of OH minus, and I can use that to find the concentration of the H plus or the OH minus. We know Kw is 1 times 10 to the minus 14th. We write the expression, we raise the H plus to its concentration in the balance equation, which is a 1, so is hydroxide. So if we were to write the equilibrium expression, it's going to be 1 times 10 to the minus 14th times x equals x times x, or equals x squared. If we divide, or we take the square root of both sides, we get that x is equal to 1 times 10 to the minus 7th. So what that's telling us is that's the concentration of both H plus and OH minus at equilibrium. So it's a tiny little bit of H plus and OH at equilibrium. So let's say we wanted to know what the hydroxide concentration is if we know that H plus is 3.5 times 10 to the minus 5, and we know that it's at 25 degrees Celsius. Well, we can write the expression. Kw is H plus times OH minus. We've done this kind of thing in our equilibrium work. The Kw is 1 times 10 to the minus 14th. So we set that, we plug in the value for the H plus, and then if we divide both sides by 3.5 times 10 to the minus 5, we get that OH is equal to 2.9 times 10 to the minus 14. Okay. Now we can only do this at 25 degrees C using this value because that value is temperature dependent. Okay. So that's our expression that we can use. So we want to be clear that K differs with temperature. So here's a value of a table of different values of Kw depending on the temperature. And you can see that as the temperature increases, the K increases. You need to memorize what the Kw is at 25 degrees C, but there'll be a table you can look up or be given values at any other temperature. Alright, so let's talk about the pH scale. So if I have my concentrations from 10 to the minus 0 all the way to 10 to the minus 14th, my pH scale is just simply the negative of the log. So the log of this here would be minus 7, so it's, because that's the exponent, but it is the negative of the log, so the pH at 10 to the minus 7th concentration is going to be 7. And if it's 7 for the pH, it's also 7 for the POH, because together they're going to equal 10 to the minus 14, and that's going to be 7 1 times 10 to the minus 7 and 1 times 10 to the minus 7, and I can add those up and get 7. So pH scale is just a simpler way of expressing concentration. Okay, and of course this only is the pH and pOH. This relationship only exists at 25 degrees C. So if I wanted to know what my pH is, I can use the negative of the log of the H plus concentration, and my pH will be the negative of the log of the OH concentration. And what I also know is that at any pH or pOH, the relationship pH plus pOH is equal to 14, and I can see that throughout here, right? Any concentration. If I'm at 25 degrees C, pH plus pOH is going to equal 14. Okay, so how do we find the H plus from the pH? Well, if we say pH is the negative of the log of the H plus, we can rearrange and multiply both sides by the negative. If you understand logs, the 10 and the log do opposite things. So I can say x is the same thing as 10 to the log of x, which allows me to cancel the 10 and the log. So I can cancel that here. So the 10 to the minus pH is the H plus. The important thing you need to know is H plus then is 10 to the minus pH. Okay, so what is the H plus of a solution with a pH of 4.4 at 40 degrees C? Notice this is not at 25 degrees C, so my kW is different. So pause it and answer this question. Okay, so hopefully you got 3.98 times 10 to the minus 5. But what we said on the last slide is that pH is equal to the negative of the log of the H plus concentration. So the H plus is going to be 10 to the minus pH. So our pH is 4.4. So I'm going to take 10, use the on my calculator, the button that, in my case, it's the second log button, which gives me, it says 10 to the x, and then I put in minus 4.4, and we get a concentration of 3.98 times 10 to the minus 5. Okay, so try this one. We have just calculated the H plus, so go ahead and calculate now the OH minus, and then come back. Okay, so hopefully you got that the answer was 7.5 times 10 to the minus 10. And what I can do is, because I knew the OH H plus concentration, I know that kW is H plus times OH minus. This is my kW, this is my H plus. I divide both sides by this number, and I get an OH minus of 7.5 times 10 to the minus 10. Note that we can't use this expression of pH equal pOH equals 14 because we're not at 25 degrees C. Okay? It only happens when kW is 1 times 10 to the minus 14th, and that only happens at 25 degrees C. Okay.